Welcome back to the exercise on chapter 15. The vehicle created in the previous exercises had two suspensions with a wheel and a vehicle body. In this exercise, you'll be adding a steering system and also a road on which you'll be running your vehicle. Okay, so go to File, Open, Model. You can also use the model from your previous exercise, or if you've not completed that and if you have some issues, you can also start with the simple car part 3 start.mdl file in chapter 15. So click on this. So this is exactly where we stopped in exercise 14. Okay, so now let's go ahead and import partially completed steering system. So go to the model, go to the import export tab, and then select the import radio button and select the steering system incomplete.mdl file. Click on open and then click on import and click on OK. So the steering system gets imported into the graphical user interface. Now just try to explore what the system contains. So it contains a body called a steering wheel, and it has three graphics, which is a steering wheel, steering shaft, and an indicator, and it has a revolute joint between the vehicle body and the steering wheel, and it has a steering motion. Okay, so these are the entities which are present inside this steering system, and as you can see, it is incomplete. Okay, now you should also note that this steering system also has attachments. So the steering wheel center attachment, the vehicle body attachment, steering shaft attachment, and also the left cylindrical joint and the right cylindrical joint. So these are the joint attachments. Okay, so you will be basically using these two joint attachments to couple the motion of the steering to these joints in the front suspension system. So now right click on the steering system and go to the add option and then go to the constraint and click on couplers. So we need to create couplers to connect the steering to the front wheels. So let's start by giving meaningful names. So steering to left wheel, and please change the variable name to steer to left. So make sure that you give meaningful names. It doesn't have to be the same thing. Okay, now you need to create another coupler. So just right click on this, say add coupler. So this is another way of adding couplers. So here give another name, left wheel to the right wheel, and in the variable name we can give left to right. Click on OK. So please note that these two couplers are placed under the steering system. Okay, so now we've just created the couplers, but still we have to resolve them. That is, we need to provide the joint 1 and joint 2. So select the first coupler, which is the steering to left wheel. Go to the connectivity tab. Let these number of joints to constraint be equal to 2. Now select joint 1 and then select or expand the steering system, expand the joints, and then click on the steering wheel joint and click on OK. For joint 2, expand the steering system, expand the attachments, and you need to select the left cylindrical joint, which was created as attachments in the steering system, and click on OK. And here make sure that the type is changed to rotational. Now go to the Properties tab and enter the ratio of the displacement between the two joints. So we'll just specify it as -1 for now. And please note that this 1-to-1 ratio is basically exaggerated, basically to make us aware how the wheel is rotating, and we'll make it and we'll give it more realistic value once we run the initial simulation. Okay, now you have to follow the similar procedure even for the other coupler. So click on the left wheel to right wheel, go to the connectivity tab, but in this case for joint 1 you need to select from the attachments the left cylindrical joint, and for the joint 2 go expand the steering system, expand the attachment and select the right cylindrical joint, and in this case both needs to be changed to rotational. Similarly, go to Properties and for now just give a value of -1, and we'll be changing to a more realistic value after our initial simulation results. Okay, so after these are done, you need to deactivate the steering motion of the front wheel. So go to the simple suspension system front, expand this, and then expand the motions, and then deactivate the steering motion. Okay, so now the steering motion from the simple suspension system front is deactivated. Now what you need to do is you have to go to the steering system and modify the steer motion. Okay, so click on this and go to Properties. Here you need to change the type from linear to expression, and then start defining an expression in the expression builder. So go in between these two expressions and give an expression of 30 times sine 2 into pi into time. So time is nothing but the simulation time that we'll be specifying, into d torque. So this expression d torque is basically to convert from degrees to radians. It is recognized by the MotionSolve solver. Okay, you can click on evaluate to see if you have any errors in your expression, and then click on OK. So that's created now. Now you can go ahead and run the simulation to test your model. So here we can keep the defaults as it is and click on run. So in this simulation you should look for the steering wheel turning and the front wheels turning at the same time as the rate of the steering wheel. Okay, so let's go to the results. So can you see that? Let me just zoom in. So this is the indicator that we created. It's moving at the same pace as how the wheel is turning, the steering wheel is turning, right? But the wheels are, taking a turn in a more exaggerated way. So we need to fine tune the coupling ratio. Okay, so now let's get back to this. So we need to update the coupler ratio. So go to the first coupler and then change the value to around -20. Okay, once this is done, again you can go ahead and run the model. Okay, you can animate the results. So now you can see that the movement is very less. I mean, the turning is not that as drastic that we saw earlier. There's a slight turning of the wheels. Okay. Now let's get back to the motion view window. Now we need to run the model on a road. Okay, so we'll be importing a road that contains contacts to represent the tire forces along with the road geometry. So for that, go to the model, go to the import export tab, import radio button, and then select the road and the contact system. Click on open and then import. Click on OK. So now you can see that the road is created. Now let's explore what is present in the road subsystem. So it has 4 contacts. Okay, so the contact front left, the left for the left wheel, the contact to the right wheel, contact to the rear left, and the contact to the rear right. So these are the 4 contacts that have been established, and because we are using contacts here, please make sure that this road surface is not 2D. It has to be a 3D, otherwise you'll be getting an error when you're trying to establish contacts. Okay, so for the same sake, we have been using a cubical graphic as a geometry and not just it's not a thin sheet. Okay, it's not a 2D geometry basically, it's a 3D geometry. So that's the graphic that we're using, and these are the hard points for the rear contact points. Okay, so now the next steps will be to drive the vehicle along a straight path with an initial velocity and along the road. So for that, let's minimize all the systems. Okay, now expand the simple suspension rear, and here you can go to steering. Okay, this one, because you don't need any steering for the rear wheels, so you can specify this expression to be 0, and that can be done by just multiplying it by 0. Okay, and please make sure that you do it for both the left as well as the right. It doesn't get updated automatically, so you need to do it separately for the left as well as for the right. And you'll also have to deactivate the ride motion, as well as the wheel motion in both the rear as well as the front suspension system. So deactivate and deactivate. Okay, so you'll also have to deactivate the fixed joint on the vehicle body. So that's there in the vehicle body subsystem. So you have to go to joints and you need to deactivate this particular fixed joint, otherwise your vehicle won't move ahead. So let's deactivate this. Now let's specify an initial velocity for the vehicle. So click on the apparent model, go to the initial conditions tab. Okay, and here you need to specify the velocity in the X direction. Okay, you can give whatever value you want. Now this is I've given it a minus 10,000 mm per second. That's because you can see the global coordinate axis, the x is pointing towards the right. So I want the vehicle to go in the opposite direction along the x-axis. Okay, so that's the reason I've given a minus sign here. Okay, now it's time to run your model. So here you need to change the simulation type to static plus transient. Okay, so once that is done, just click on run. Okay, with all these contacts established, it's going to take a bit of a time for solving this analysis. So please give it some time. Yes, so solved. Now let's go to animate. Okay, now click on the animate button and you can see that your vehicle is moving forward. Okay, so let's bring it back. Please zoom in. So can you see the vehicle is moving a little bit towards the left and a little bit towards the right? Okay, let me replay this animation for you. And you can see the steering wheel turning. Okay, that's done. And what do you expect when it comes to the end of this road? It should fall off, right? Because of the gravity. So let's continue to play the animation. So your vehicle falls off the road. Okay. So this completes all your chapters in the Multibody Dynamics course. Okay. So what you can do is, if you don't want your vehicle to fall off, you can either switch off the gravity, or you can come back to your motion view window, and here for the simulation time it can be just like 3 seconds. So now let me just run the simulation once again. Okay, animate. Let me expand the window. So then you can prevent your vehicle from falling down. Okay, you just have to reduce that simulation time. Okay. Okay, then that's the end of this particular chapter. Thank you.